Hello everyone, welcome back to another video in our ASP.NET Core and Ocelot series. I hope you are all doing well and excited to dive into another essential feature of API gateways. Today we are going to explore rate limiting with Ocelot in ASP.NET Core, a great tool to manage and protect your APIs from excessive requests. But before we jump into this, let's quickly recap what we have covered so far to set the stage for today's topic. In our previous videos, we've laid the foundation for understanding API gateways by working through a few core features with Ocelot. We began with a straightforward look at routing. Ocelot makes it easy to manage different routes in our application, allowing us to direct requests to the appropriate backend services. If you haven't seen that video, I encourage you to check it out because solid routing is at the heart of any effective API gateway setup. After setting up basic routing, we moved on to authentication and authorization. This was an essential step as it showed how to secure endpoints, ensuring that only authorized users can access specific resources. Using Ocelot's features, we configured policies that help keep our applications secure by managing who has access to which part of the API. In our last video, we explored load balancing. This feature allows us to distribute requests across multiple instances of our backend services, improving both reliability and scalability. We set up round-robin load balancing, enabling our API gateway to handle high traffic more effectively by sharing the load. Each of these videos is available on my channel, so feel free to go back and watch them if you need a refresher. Now you can also download the complete project from my GitHub. Our links are provided in each video description. These resources should help you solidify your understanding and follow along with today's tutorial. Now let's turn our attention to rate limiting. Rate limiting is a critical feature for any public-facing API. Essentially, it helps prevent abuse by limiting the number of requests a user or a client can make within a specified time frame. For example, if we set a rate limit to 10 requests per minute, any client exceeding this limit will be temporarily blocked. This protects your backend services from being overwhelmed by too many requests at once and helps to maintain performance and availability. In this tutorial, I'll walk you through setting up rate limiting with Ocelot in ASP.NET Core, covering every step from configuration to testing. By the end of this video, you'll know exactly how to implement this feature and have a robust rate limited API gateway setup. So let's get started and dive into the world of rate limiting with Ocelot. Alright, before we dive into implementing rate limiting, let's quickly revisit the projects we've been working on and the setup we already have in place. As you know, we've been working with 3 projects. Target API Sample, this is one of our backend APIs running on port 5001. It serves as a downstream service behind our gateway. Target API Sample 2, this is another backend API running on port 5002, which also acts as a downstream service. And finally, Gateway API Sample. This is our API gateway project powered by Ocelot. It's the central point of entry for all client requests. We've configured it to handle routing, authentication, authorization, and load balancing. In the last video, we set up routing to direct incoming requests from the gateway to the appropriate backend service. We also implemented authentication and authorization, ensuring only authenticated clients with a valid token can access the APIs. Finally, we added load balancing with a round-robin strategy. This means when you make a call to the gateway endpoint, the request alternates between Target API Sample on port 5001 and Target API Sample 2 on port 5002. Let me show you how this works before we move on to implementing rate limiting. Alright, let's fire up all 3 projects: Target API Sample, Target API Sample 2, and Gateway API Sample. Once they're running, we will switch over to Postman for testing. First, we need to get an authentication token from the gateway. For this, we will use the token method in our gateway API sample project in Postman. Select the Postman method, API authenticate token, and hit send to authenticate. If everything is set up correctly, you will receive a token in the response. Copy this token, we will need it for the next step. Now let's test the endpoint. This is the route we've configured in the gateway to demonstrate routing and load balancing. Select the get method in Postman, go to the authorization tab, select bearer token and paste the token you got in the previous step. Hit send to make the request. For the first request, you'll see a response from Target API sample on port 5001. And if I hit the send button again, for the second request, the response will come from Target API sample 2 on port 5002. This behavior is because of the round robin load balancing we implemented with Ocelot. Every subsequent call alternates between the two backend APIs, ensuring a balanced distribution of requests. So far, we've successfully authenticated routed requests and tested load balancing. Now imagine if one of your clients sends an excessive number of requests. Without any controls, this could overload your system and affect other users. That's where rate limiting comes in. It allows us to define a limit on the number of requests a client can make within a specific time frame. Let's jump into implementing rate limiting with Ocelot and see how we can safeguard our APIs. We will add this feature to our Ocelot.json configuration in Gateway API sample project and test it again with Postman. So let's do it. Alright, we've just finished testing the routing, authentication, authorization, and load balancing setup in Postman. Now it's time to extend our API Gateway sample project by implementing rate limiting in Ocelot. This will allow us to control how many requests a client can make within a specific time period. Let's open up our Ocelot.json file and start making the necessary changes. To implement rate limiting, Ocelot provides built-in options that we can add directly to our route configuration. Here's how we modify the route section in the Ocelot.json file. Add the rate limit options to the route like this. After that, I'm gonna add enable rate limiting. This turns on rate limiting for the specific route. Then client whitelist. You can use this to exclude specific clients, for example, trusted services or admins from rate limiting. We are leaving it empty for now. And next is period. This defines the time period for rate limiting. Here we've set it to 1 minute. After that, we have a period time span. This parameter indicates the time in second after which a retry is permissible. During this interval, the exceeded message will appear in the response, accompanied by an HTTP status code. And finally, we have limit. This sets the maximum number of requests allowed during the specified period. In this case, 5 requests per minute. Now that we have added rate limit options to our Ocelot.json file in the Gateway API sample project, the next step is to ensure that all necessary projects are properly configured and running together. To achieve this, I've added the Target API sample and Target API sample 2 projects to the same solution. Here's what I did. In Solution Explorer, I right-clicked on the solution file at the top and selected Add then Existing Project. Then I navigated to the folders containing Target API sample and Target API sample 2 and added their respective .cs project files to the solution. Now all 3 projects are part of the same solution, which makes it easier to manage them. Once the projects were added, I needed to ensure that all of them would run simultaneously. This is where the multiple startup projects feature in Visual Studio comes in handy. I right-clicked on the solution file again and selected properties. In the solution properties window under startup project, I chose multiple startup projects. I set gateway API sample, target API sample, and target API sample 2 to start in the drop-down list next to each project. This setup ensures that when I hit F5 or run the solution, all three projects will launch automatically. With this configuration, I don't need to start each project manually. All three projects, gateway and the two target, will be up and running at the same time. This is especially useful for testing scenarios like routing, load balancing, authentication and authorization, and now rate limiting. Okay, now let's move on and test the final part of this scenario. Now we can run all three projects and test rate limiting with Ocelot. Alright, now that we've set up rate limiting in our Gateway API sample project, it's time to test the configuration. As a quick recap, we have configured the rate limit options in the Ocelot JSON file to allow a maximum of 5 requests per minute. When we exceed that limit, we should receive a 4 to 9 too many requests error. Let's walk through the testing process step by step to see it in action. First, I'm gonna run all three projects. I mean, Gateway API sample, Target API sample, and Target API sample 2. Since we've already configured multiple startup projects in Visual Studio, I'll just hit F5 to start them all simultaneously. Once the applications are running, we will have Gateway API sample listening on port 5000, Target API sample on 5001, and Target API sample 2 on 5002. And now let's get a token to authenticate our requests. Open Postman and send a post request to this endpoint. Once the request is successful, you'll receive a JWT token in the response. Copy this token, go to Authorization tab in Postman, select Bearer token and paste the token there. And this will authenticate all subsequent requests we send to the gateway. Now we are ready to test the rate limiting feature. Send a GET request to this endpoint through the gateway. The first request will be routed to Target API sample on port 5001, and the second request will be routed to Target API sample 2 on port 5002. Thanks to the round robin load balancer we've configured, the requests will alternate between these two APIs. Send 5 requests one by one. Everything should work perfectly, and you'll receive the weather forecast response from either Target API sample or Target API sample 2. Now send a sixth request. And this time when you send the sixth request, you'll notice a significant change. Instead of receiving a successful response with weather data from either Target API sample or Target API sample 2, the gateway will block the request and return a 429 too many requests error. This error code is critical. It tells the client that their request was valid but couldn't be processed because they've exceeded the allowed request limit. The reason for this is the rate limiting rules we defined in the ocelot.json file. Let's break it down. When the gateway detects that more than 5 requests have been made by the same client within this period, it automatically enforces the rule by blocking further requests. That's why on the 6th attempt, the gateway returned a 429 error, signaling the rate limit has been exceeded. Okay, this is how you implement rate limiting in Ocelot. As you've seen, it's a simple yet powerful way to control API traffic and protect your backend services. Alright folks, let's recap everything we have accomplished so far in this journey with Ocelot as our API gateway. We started by implementing routing, a core feature of Ocelot that helps us define how requests are directed to our backend services. Next, we added authentication and authorization, ensuring that only authorized users with valid tokens can access protected resources. After that, we explored load balancing using the round robin algorithm. We saw how requests are distributed across multiple instances of our backend services. And finally, today we implemented rate limiting. We configured Ocelot to restrict clients to a maximum number of requests per time period, preventing abuse and ensuring fair usage of our APIs. In the next video, we will dive into another exciting feature of Ocelot, caching. Caching can significantly improve performance by reducing the load on your backend services and speeding up responses for repeated requests. I'll show you step by step how to set it up and configure it effectively in Ocelot. So stay tuned for that. If you found this tutorial helpful, make sure to like this video and subscribe to the channel for more content like this. Don't forget to hit the bell icon so you'll be notified as soon as I upload the next video on caching in Ocelot. Thank you so much for watching, and as always, happy coding. I'll see you in the next video.